Product search gets messy when review text and product data live in the same document. I'll show how parent-child queries in Elasticsearch fix that cleanly in Python. This is the setup you'll be able to run after this, which indexes products and reviews separately and ranks products with clean review boasts. I'm Professor Pi, teaching search and IR with simple Python. Search systems for product pages often mix product attributes and review text in one big blob. That looks easy at first, but it causes two problems. First, updating a single review forces rewriting a big product document. Second, scoring gets noisy when long review text drowns out structured fields like rating. Parent-child solves both by storing product as a parent and review as a child. Linked but separate. That keeps updates cheap and scoring flexible. The intuition is simple. Keep the canonical product document small. Put every review in its own document that points back to the product. When you search, ask Elasticsearch to find parents that have matching child reviews. You then decide how to combine review relevance with product-level signals like rating. Strengths are cheap updates and clearer scoring. The trade-off is slightly more complex indexing and the need to use routing so children land with their parent. We will build a tiny demo you can run locally. It creates an index with a join field, writes 2 products and a few reviews for each, then runs a relevance-only search and a blended search that combines review text with product rating. I will point out routing and how score blending works so the code feels straightforward before you run it. First, we connect to Elasticsearch and check the server. This snippet connects to Elasticsearch and verifies the cluster is reachable. The Elasticsearch object builds a client pointed at localhost, which is the default development endpoint. The variable ES holds the client instance, so later steps can reuse it. The call es.ping checks that the server responds to a lightweight health probe and returns a boolean. The variable IDX names the working index so the tutorial keeps a consistent target. If ping returns false, the server is not reachable at that address, and you should start it or fix the URL. The printed values confirm connectivity and show the index name used next. Next, we prepare the index mapping so products and reviews can coexist. This example creates a parent-child index mapping with the join field in Elasticsearch. It first checks whether the index exists and deletes it to ensure a clean slate. The dictionary mappings defines a join field named rel that declares the relation product to review, plus simple fields for product and review text, and a numeric rating. The call es.indices.create applies this mapping, so parents and children can be stored in the same index without flattening. Then es.indices.getMapping reads back the mapping to derive the relation string for confirmation. The printed values confirm we started fresh and that the join relation is product review. Now we add toy data for 2 products and their reviews. This code indexes 2 products and their reviews using Elasticsearch routing and the join field. The list products holds parent documents, each with name, brand, and rating. For each parent, the call es.index sends a document where rel is set to product, and routing uses the product ID so child documents can co-locate. The list reviews holds child documents that reference a parent ID. Each child is indexed with a rel object naming review and its parent, and routing set to the same parent ID. After writes, es.indices.refresh makes them searchable immediately. The printout confirms the total documents written to the index and the target index name. Next, we run a search that ranks products only by review text. This snippet searches for parent products ranked by matching review text using Elasticsearch's has-child query. The variable Q defines a query that looks for child documents of type review, whose body matches the word water. The score mode set to sum aggregates child scores onto their parent, so parents with more or stronger matches can rank higher. The call es.search executes the query and returns only the product source fields we care about. Here, the name. The code extracts the first hit, reads its score, and rounds it for readability. The printed product and score show the top item driven purely by review relevance. Finally, we blend review relevance with product rating for a balanced ranking. This example blends child review relevance with product quality using Elasticsearch's function score. The inner query uses has-child to match reviews containing water or rock, with score mode set to max, so only the strongest child match contributes. The functions array adds a field value factor on the parent's rating, using a square root modifier to dampen extremes, while still preferring higher ratings. Setting boost mode and score mode to sum adds the rating-derived boost to the textual score for a clean, interpretable blend. Increasing the factor strengthens the impact of ratings. Decreasing it prioritizes review text more. The printed name and blended score show which product wins under the combined signal. To map this toy demo to a real project, treat each product ID as your stable primary key, and use routing so reviews and product stay on the same shard. In production, you would batch writes and monitor refresh frequency to balance indexing latency and search freshness. Recap: parent-child stores products and reviews as linked but separate documents. Use it when you need frequent review updates or when review text should not overwhelm product fields. Caveat: it adds some indexing and query complexity and requires attention to routing. Next step: tune the field value factor on rating versus the text score to find the right balance for your users. If practical, hands-on IR helps. Subscribe and watch the rest of the search videos.